Hi everyone, so today we're going to talk about separable ODEs and how we can approach them. I hope you enjoy.
Let's go more in depth in the concept of separable ODEs.
So, separable ODEs.
So a separable ODE, as we can recall from last time,
has the following format: a function of x plus a function of y times its derivative is equal to 0.
and we can rewrite this expression here
The following form: m of x plus n of y times its derivative is equal to 0.
Just this change in notation showing the two differentials is going to help us when we're separating the variables.
So let's subtract m of x in both sides, and we're going to have n of y times dy is equal to, multiplying also by dx on both sides, we're going to have negative m of x times its differential dx.
So now we see that we have
All of the variables with respect to y on one side, n of y times its derivative, and we have all the variables with respect to x on the other side times its differential dx. Now what we do is we integrate both sides, and we can solve for our solution y.
So let's get through some examples.
This is going to become a little bit clearer once we go through some examples, because this is just showing the overall method, the general case of solving
A separable ODE. And the trick here, or the strategy, is to try algebra to separate the variables. And we'll do this for this example.
So this example, we have y prime
Is equal to
x squared over y times 1 plus x cubed.
So this is our example. The first thing we do
Is we check if this ODE is linear or not. So we know if we multiply this expression in the bottom in both sides, we're going to have y 1 plus x cubed times its derivative is equal to x squared.
and we know that in a linear ODE,
We can't have this relationship y times its derivative. So this is not linear or non-linear, however you want to phrase it, linear. So this is non-linear. But to our, it's good because it's separable, and that makes things a lot easier. So it's separable because we have this, we can rewrite this as dy dx. dy dx is equal to x squared over y 1 plus x cubed. And then we can separate the variables. Here what we can do is that we multiply by y on both sides. So if we multiply by y, we're going to have y times dy. And if we multiply by dx on both sides, we can get rid of this dx, and we'll have x squared over 1 plus x cubed times dx. So now we have this function of y times its derivative and this function of x times its derivative. We simply integrate both sides, and here we just evaluate the integral. So it's going to be 1/2 times y squared, and we could put the constant in only one side. We don't need to put constant on both sides. So I'm just going to put the constant on the right hand side for this problem. And how do you solve this integral? I think it's the easiest way is to do substitution. So we're going to say that u is equal to 1 plus x cubed. And if you take the derivative du, we have 3x squared times the differential dx. And the way I like to do it I usually solve for dx, which is du over 3x squared. And if we substitute this into this integral, I'm just going to do some side work over here to solve this integral. So it's going to be the integral of x squared over u times du times 3x squared. So the x squared just cancels out. So there's a factor of 1/3 here. We can pull that out. So it's going to be 1/3 times the integral of 1 over u times du. And the integral of 1 over u is simply ln of u. So it's going to be 1/3 ln of the absolute value of 1 over x cubed. And sorry if this side work is pretty sloppy. I don't like to go writing in the board like this, but it's good for now. It's just side work. So we're gonna have 1/2 y squared is equal to 1/3 ln of the absolute value of 1 plus x cubed plus a constant c. So if the question just said to find the general solution of this ODE, or just solve this ODE, this would be fine because this is already an implicit solution. So this is already one of the solutions, and it depends on your professor. Depends on the professor that you take your differential equations class. But usually it's better to leave it in the implicit form because you don't have to do a lot of algebra to simplify it. But some professors really want you to write it in explicit form. So if that was the case, you would multiply by 2 on both sides. So multiply by 2 and take the square root, basically. So we're going to have y is equal to plus or minus square root of 2/3 ln the absolute value of 1 plus x cubed plus another constant, I don't know, k or c1, because we're going to be multiplying this 2 by c. It's just another constant, but I don't know how strict your professor is, so we can leave it like that. So this would be the explicit solution, and this would be the explicit solution, and this would be the implicit solution. So this was just one example. I'm going to do one more, and then we're going to move on to homogeneous ODEs and how to solve them. I hope you enjoy. If you have any questions, please leave a comment. Thank you very much for watching, and I'll see you next time.